All right. Well, thank you everybody for joining. We're excited about this partnership with York University. My name is Jade Alberts, the Vice President of the Canadian Blockchain Consortium. For those of you who don't know who we are, we have been founded about 7 years ago with Kalea Carrington. We've been expanding this, what we do over the last 7-ish years. And we were founded to unite Canada's diverse community of blockchain business owners, developers, adopters, and those interested in exploring this technology. We have transformed a little bit into becoming the industry leader in voice and really focusing on regulations, working with governments and promoting, the Canadian industry around the world. We are viewed as one of the leading experts throughout the world, and Kalea speaks all over North America. We've spoken in England and France, Spain, Portugal, Germany, Bermuda, the Bahamas. So we have done a very good job on making sure that we are included on everything that goes along and making sure that it is something that Canada is not left behind. So if you have more information, please visit our website, canadablockchain.com, or sorry, .ca, and please reach out to us. But again, yeah, this course is something new for us. It's the first time that we're going to be trying this, and I would like to introduce Dhruvin Parikh. He's a distinguished software developer and leading blockchain startup in Toronto, specializing in decentralized systems. Since 2017, Dhruvin has been at the forefront of blockchain technology, contributing to major open source projects within the Ethereum and AION and Polkadot ecosystems. His technical experience encompasses clean, effective coding, React, and React Native and Node.js. In addition to his industry role, he serves as an instructor at York University School of Continuing Studies, where he designs and delivers advanced coursework in blockchain development, including full stack development, smart contracts, and decentralized applications. He also operates a consulting firm in Canada, providing specialized services for decentralized applications and solidified smart contracts, while operating hardware and firmware design solutions to pharmaceutical and utility companies in India. Dhruvin, the floor is yours. Take it away, my friend.
All right, thanks, Jade, for giving a nice introduction. I just need a permission to share my screen.
Trina, can you please do that?
Just taking a look here, sorry. He doesn't have permission. You should have availability now.
All right. Yeah, I have the permission. Okay. Is my screen visible?
Yes, I can see your screen.
Okay, awesome. All right. So I just want to spend a couple minutes to talk about York University's program in certificate in blockchain development. So this program is, going to help you to analyze the appropriateness of the blockchain for the business use. This program is also, going to be, teaching you about the consensus mechanism, and it includes developing blockchain applications on, different platforms. It also helps to, it also helps a student to analyze a use case and whether it's, suitable to be developed on top of blockchain or not. It also includes, students to perform some of the hands-on, for setting up the nodes, building the interface. So it provides a 360-degree view to the student, along with, working at each level. That includes the application level, infrastructure level, and the presentation level as well. It also teaches about different use cases and its validity. This program is not just limited to the technical skills, but it also helps student to inculcate communication and active learning skills. So I'm one of the part of the instructors at York University in the certificate in blockchain development program. So I have been affiliated with the industry, and I do have on daily basis I am the part of many major protocols during my tenure. So that really impacts the curriculum here. So by when the students are going to graduate, it's going to help them. We're gonna basically teach them to create a portfolio which they would be able to showcase to their employers. It is not only that, it includes a caption part as well, which gets a student an opportunity to be a part of industry setting and work on a real world use case. There's also an option for blended study, which includes a combination of asynchronous and on-campus classes. So it becomes really convenient for the user to attend the classes where it's beneficial to be online, just like we are doing. And also there's another option which is on campus. So it's not an option, but there's actually a combination. So that actually comes out to be a good blended option. This program lasts for 3 months, so student has a benefit of graduating from this certificate in blockchain development as fast as in 3 months. So here are the contact details, which you can just take a screenshot. Anyway, I'll be resharing the contact details slide when we will be wrapping up the session. So the main purpose that we are meeting today is for delivering a mini class for certificate in blockchain development. And we will be zooming into ETH liquid staking, which is currently the most trending opportunity in the DeFi space. Of course, there are a lot of use cases in blockchain, but we will be zooming in, or we will be focusing more on that in our today's session. So my first name is Dhruvin, my last name is Parikh. My background has been introduced beautifully by Jade. But however, I am a DeFi developer and Web 3.0 instructor. Currently, I am, working as a senior blockchain engineer with Frex Finance. I'm also a blockchain instructor at York University. Before that, I was VP engineering at Dinero Protocol. I was CTO and lead blockchain developer at Optify, which was an yield aggregator platform. And before joining York University as the blockchain instructor, I used to teach blockchain at Georgetown College. So I have been in the space, in the teaching space of blockchain since 2019, and I started digging deeper in this space since 2017. So I have more than 5 years of professional experience shipping like a lot of applications. Some of them have TVL of around 2 million to 200 million USD as of today. Just in case if you would like to get the slides handy, I'll just post it in the chat. Right. So the outline for today's classes, we're gonna start from the ground up about we're gonna do a very brief refresher on blockchain consensus mechanisms, proof of stake in Ethereum, how it works. It is not going to be super technical, but it will be a bit technical, of course. I have tried to make it in a way where the audience from from all the spectrum could consume something by the end of the class. We'll be talking about blockchain use cases, to be specific, liquid staking. We will be understanding how liquid staking works. How are we leveraging the feature of Ethereum of having smart contract and its transition to proof of stake, and when you combine both of these features, how you can derive a use case out of all its inherent qualities. And that's what we term it as the liquid staking. What are its risks is also we will be looking into, and of course, what are the opportunities that we have out of the liquid staking protocols. So a blockchain is a distributed database where everyone agrees on basic set of rules on how it will be changed. Database, it's just, you can imagine as a table which has got some entities, and if you want to make any change, there will be a sort of approvals that needs to be taken by the participants or by the nodes who are actually the part of that distributed database network. Whenever you are, for example, making an update or insert or delete query to any database, it actually is what we call it as transactions into terminology of blockchain. The difference between our conventional database and the one that is being employed in the blockchain is about the immutability. So once you're making any changes to the data on the database, it becomes immutable, or you cannot change anything unless and until you have got consensus from the network. Consensus means everybody agrees on making some change. So if a blockchain is an ideal blockchain, which means that if it is working properly, then everybody is going to have a same copy of the DB. So redundancy is one of the important feature of the blockchain as well, which means that if you're making a change, if a node is undergoing any change, then all the other nodes in the network will undergo the same change. That's the consensus. So based on that, Bitcoin came. This is a very simple mental model of how the Bitcoin blockchain looks like. Of course, blockchain is a simple linked list where in here we don't have anything related to memory, but the hash of the block is related to hash of the hash of the current block is related to hash of the previous block. If it was a Genesis block, then the previous block the previous block hash is going to be null. And each block is going to have multiple transactions. In Bitcoin, we know it is just transfer of values, which you will be able to see. And there are certain paradigms for accounting of the balance of the users. But we are not going to go. We are not going to spend a lot of time here. I'm just going to talk about some of the limitations that Bitcoin had, and then we came blockchain 2.0, which we call it as Ethereum, which introduced programmability, right? So wherein there is a virtual machine part which can handle execution of a code. That code is such which is going to execute as it is written. So as we know that it's immutable, blockchain has immutability. Which means that the code that you are deploying, it's just like a microservice that you deploy on the cloud, and it just works whenever it is invoked. Similarly, whenever you are making a transaction, that is where the smart contract code, the functions in the smart contract code are going to get included. So of course, who are going to be the part of this whole ecosystem? There will be validators who are going to contribute to the security of the network. When Ethereum was in proof of work, we used to call them as miners, as we do in Bitcoin. Right now, as the Ethereum has transitioned to proof of stake, is what we call it as the validators, because they basically perform the job of, validating a block or testing a block. It's like cryptographically signing that this block is, what I as a validator is endorsing. So it will be aggregated, and once, all the validators, depending on a certain specification of the consensus protocol, they agree, it's going to be added, to the block, right? So, what got introduced in blockchain 2.0 to make blockchain programmable is, a runtime, which can execute some code, and the fancy name which was given to it is a smart contract. But so it is a part of, it is, a very fundamental building block of Ethereum, and it is part of the Ethereum's application layer. So in order to understand what a smart contract is, it is nothing but a programmable agreement, which just follows, if this, that logic. The reason that we are including, the smart contract is when we'll be talking about the liquid staking, it is nothing but a protocol which is, realized using smart contracts, using, group of smart contracts only. And also Ethereum's proof of stake was was only possible because of Ethereum's feature of, having it to be a programmable blockchain by introducing smart contracts, right? Otherwise, the merge that occurred in 2022 would not have been possible, right? So because of immutability, we will be having a guarantee that, whatever you see is what you're going to get executed. In order to create a smart contract, you have to make a trigger to the network. You have to make a trigger to the blockchain, and that trigger is what we call it as a transaction, which means that you are making a change to the database, and that particular database which lies in the node. The node is a machine that runs, blockchain softwares, and it also has one of the component called virtual machine. Ethereum is what we call it as Ethereum virtual machine. It's a runtime. It's just like analogous to, Java virtual machine, which is used for running any Java programs. And, there are languages to it, which we use, which are English-like languages, so that we as a developers can write it down. And, there are certain toolings which gets converted into the language called bytecode, which will be understood by the virtual machine that runs as a part of the node. So, having said that, you need some sort of, some assets, or you need to spend something in order to, deploy, or in order to transact with the chain. Those assets are what we call it as the coin. Generally, this is by convention. It is nothing wrong to by mistake call coin to be a token or token to be a coin, but just to, for this session, just to differentiate between the both, what we do is coin means it is a native currency to the chain. So Bitcoins, for Bitcoin, it is BTC. For Ethereum, it is ETH. And for example, for Monero, it is XMR. However, tokens are actually smart contracts, right? Which are written by implementing certain standards like ERC20, ERC721, ERC1155. So ERC20 is an example of fungible token standard, and stablecoin is one of the use case of that. So if you talk about DAI, USDC, they are all smart contracts. But as they are implementing a standard called ERC20, is what by convention we call them as token, right? However, the inherent nature of coin and token, they are quite similar. They both are used for exchange of values. They both are used for having a ledger in which you have a lookup table of the account holders to the balance of coin token that they have. So that's how we basically differentiate between a coin and a token. So there are many use cases for the blockchain. Like we can issue stable coins. There are a lot of types of stable coins. There are algorithmically backed stable coin. There are centralized stable coins like, USDC, who have got backing of, real US dollars. In the bank account, we all know about the SVB case. Then you can also create and distribute digital assets on the blockchain. Decentralized gaming is currently taking pace where, you can do certain gambling. You can implement certain, casino games like roulette, etc. Decentralized exchanges, which performs, automated money market, is one of the very popular use case. Like you can do trading between one asset and another asset. And then another use case that have been emerged since the merge. I mean, of course, I would say the use case was already discovered, by Lido even before the merge was happened, and is what we call it as the liquid staking. Okay, so now going forward, my focus will be mostly towards liquid staking. So whatever is required in order to understand this concept is what we'll be covering. So we have got mainly two types of consensus mechanisms. There are, of course, a lot of consensus mechanisms, but they are all variants of proof of work, proof of stake, right? So proof of work, which is used in Bitcoin, uses Nakamoto consensus, right? The proof of work which was used in Ethereum is what we call it as the ETH hash, right? So there is a change in algorithm, but at the end of the day, proof of work is something that is going to generate a number which is going to give you a hash that is going to have some preset number of zeros in the beginning. So that's what is proof of work. So consensus mechanism, all in all, is in terms of blockchain, in terms of Ethereum, is a stack of protocols, incentives, and ideas, which is going to allow a network of node to agree on state of the blockchain. We all know about the game theory and mechanism design and blockchain, and that is something which is central to blockchain. Otherwise, we won't see any operators, we won't see any miners participating if there were no incentives. So if we talk about proof of work in form of a flow chart, this is what I just explained, where you have to generate a number which you call it as the nonce. So that nonce gets generated by by iterating through different values. That will help you to get a hash number that will have a particular format. So the nonce which will help you to get that particular hash number with the format, and whoever is going to generate this nonce first is the one who is going to win that race and will be awarded the block reward. That's what happens in general in Bitcoin and Ethereum's proof of work. Whereas if we talk about proof of stake, it can be very well understood by comparing it with proof of work, wherein we basically allow a miner, or we basically allow a node to win in proof of work by measuring, which depends on the hash rate of the node. Whereas if you talk about in proof of stake, it will be depending on how much stake or how much money that particular node operator has staked, or that particular node operator has locked in the network. And depending on the percentage of the stake that the node operator has locked is what will depend on how much reward that staker or the validator is going to earn. Now, in terms of how the proof of stake works on Ethereum is a bit different than what we are generalizing it here. In Ethereum, we don't have option for the validator to stake with any amount. It is fixed at 32 ether. So you have to stake 32 ether in order to get the permission for attesting a block or for validating a block or for becoming a validator. And then the network is going to randomly pick any validator that is going to be random in nature, and then they will be assigned a duty for proposing a block, right? So that is random. However, there is another layer that got added after the merge, which we call it as the consensus layer or beacon chain, that will continuously enable the validators to earn the rewards for attesting a block, right? So which means that they are actually endorsing a block, that this block should be added to the chain, and that will not be the only validator. There will be a group of committees. There will be a group of validators, which we call it as the committees, who will be assigned the duty, and that is like another way of earning the reward. So in Ethereum proof of stake, the rewards that they will be earned will not depend on how much weight that they have or how much amount of ETH they have staked. If they had staked more than 32 ETH, then the network is going to refund the delta to them. That's how the specification of consensus of Ethereum consensus protocol states, and that's how it is implemented. So what happened is after the merge, there are now two chains, right? One is the beacon chain, and another is the execution layer. So execution layer is the same that was before the merge, which we called it as the Ethereum mainnet. It used proof of work, but now we have got two layers. One is what we call it as the execution layer, that is realized by execution clients. There are several teams across the world who have developed the implementation of execution client. The first one who did it originally is Go Ethereum by Ethereum Foundation. Then we have got Hyperledger, Bash, Nethermint. They are softwares, and similarly we have got consensus client softwares as well, which we call it as ETH2, and the name for them is Prism. This name is Prism. And we got Nimbus, Lighthouse, Takeo, etc. So whoever runs Ethereum validators, they will be running at least any of this two softwares, either one from the execution client ETH1 or anyone from consensus client ETH2. And if they want to be a validator as well, then they will have to run a third software, which was not the case before the merge. They just had to run one client software, either Go Ethereum or any other ETH1, and that just worked. But that's not the case right now. So this is how currently at a high level running the node, or what happens in the what happens when a node would like to become a validator is, right? So what changed in Ethereum proof of stake after the merge is the responsibilities. So previously, execution client used to perform the consensus logic, all the fork choice rules, peer-to-peer communication, which we call it as the block gossip with other peers. But all those responsibilities were segregated, and it was implemented in a different layer, which we call it as the consensus layer, realized by the consensus client. And the softwares which does that is what we looked in the previous slide, which we call it as ETH2, right? And what was kept with the execution client was transaction handling, all the transaction gossips. For example, if you are broadcasting a transaction to the Ethereum network, you will be talking to the execution client, and execution client will be responsible for relaying all those communication for transaction to other peers in the network. The Ethereum virtual machine is also the part of execution client. Ethereum virtual machine is the one which is a runtime for executing our smart contracts. And then the state management. So every time, you are making a transaction, there is a change in the data that is going to undergo. So that is also responsibility of the execution client. And there was some changes in the execution client softwares were made that enabled it to, communicate it via some API specifications with the consensus client. And that is what we call it as the engine API. So this was a change. So this is how the current network architecture of Ethereum in proof of stake mechanism looks like. So everything that you see on the right hand side here, they are all the nodes, right? And yeah, so they are the one which we call it as the peers. Okay, so the question is, what is the process of staking on Ethereum? So, or what do you mean by staking on Ethereum? So it's nothing but you just need to lock your token, and then whatever period that you'll be locking your token, you're going to earn rewards on top of that. The rewards will be in ETH. So there are mainly two types of rewards. There are also like more type of rewards like MEV rewards, but MEV is not native to Ethereum. So attestation rewards are the rewards that you're going to get on the Bacon chain. So, every epoch, your validator should be assigned a duty. And if your validator is, not online when within those one epoch when the duty was assigned, then your validator is going to undergo penalty, or it will be, receiving some slashing conditions, right? But what the spec says is every epoch or every 6.4 minutes, you should be given a duty for attestation, where it is similar to your validator voting to propose a network, right? So that's on the Bacon chain, which is being realized by the consensus client. And then there are block rewards. They are our original rewards that any proof of work blockchain like Bitcoin or Ethereum proof of work had. So whenever a validator is randomly assigned duty for adding a block on execution layer, and if the validator did it correctly, then validator is going to receive the block rewards. So whichever validator will be responsible for adding a block to the chain, which is of course randomly done, is where the MEV rewards or minor extractable value rewards come in. But that is something which is not native. It is an external mechanism that is as a result of some economic benefits, for example, for trading between token and token B. So staking is a mechanism through which you will be the part of you will be able to contribute to the network security, and at the same time you will be able to earn the rewards, right? So again, this is where incentives are centered in the space. We used a jargon called epoch. So an epoch is actually a group of slots. It has got 32 slots. Each slot lasts for 12 seconds, and what we call it as blocks on execution layer, here is what we call it as the slots. The reason that we have slots and epochs mechanism is we want to make sure that each validator is given duty to attest a block in 6.4 minutes, or within a span of 32 blocks, right? So that's a reason, right? And also this slots and epochs are used for measuring the delay that a validator will have to face the moment they have staked 32 ETH, because when your validator has staked 32 ETH, it is not going to get started with the validation right away. It will be kept in the queue after some sanity checks that are being done by the network. Then after passing of some epochs is where the validator will be in the active state, and now will be able to actively validate, right? So this is how you can stake, which is like the step 0 for becoming a validator. You need a bag of 32 ETH, which you need to stake to a deposit contract. Deposit contract is like an agreement, right? So you have to sign it, you have to write how much value you are willing to stake. You have to also specify your, account which will receive the rewards. So that is something which is done on execution layer, and hence we have, we are calling it here as ETH 1.0. After, you make a deposit, there will be an event that is going to get emitted. Event is like a notification, which is one of the property of a smart contract on Ethereum. And that notification will be listened by the consensus layer, right? By the consensus client. Consensus client is going to, verify thoroughly that the deposit wasn't as a result of a false notification, and it is genuine. So once they are able to do that, of course, it's going to take some time. So that time is measured in epochs, right? So it has to wait for 32 epochs, right? So you can just make a calculation. One epoch is 6.4 minutes. So, it's around, 0.5 to 3.5 hours of time, which Bacon chain is going to take in order to process the deposit. Now, why I'm, putting a lot of emphasis on this portion is these are some of the limitations that you might be thinking in your mind. And ETH staking is a way where, all these limitations can be, we can solve it. ETH staking is not natively available on Ethereum. But, we can take the features of Ethereum like smart contracts, and we can somehow, make liquidity available so that the users who have deposited that 32 ETH or users who have deposited ETH in any amount can, unstake it whenever they want to, and they don't have to go through all these native mechanisms that Ethereum proof of stake has. So this is like a very, low level process that any node will have to, undergo if they want to become a validator. So they'll be the part of the queue after, the deposit has been processed and sanity check has been done. After few epochs, it will be the part of Bacon chain to be staking, and the status is what we call it as reactive. So this is how a validator can become, this is how a validator can actually start staking on Ethereum, right? Okay, but one thing which you noticed here is some of the demerits. So you need to have 32 ETH, right? Now there are a lot of retail users who want to be the part of the staking process, but they might not be able to stake 32 ETH at once. But that's a requirement of the network. That's one limitation. Another limitation is the timing. If you want to become, if you want to start, earning the rewards, you have to wait for some time, even though if you have got 32 ETH, right? And then there is also a wait time for unstaking. So I haven't shown it, but of course there is similar, diagram where, there is a request which you will have to make to the Bacon chain so that you can now, safely exit from the Bacon chain and you can get your staked portion, back into your account. That's also going to take, like 1 to 2 weeks. So these are some of the limitations which we have it right now. If you want to natively stake or if you want to perform solo staking, right? Which is, by the way, a gold standard. So one of the option is solo home staking. Of course, you need 32 ETH for that. You need your own infrastructure. You also have to make sure that it is powered, uninterrupted. Staking as a service is where you are trusting somebody else's infrastructure, but you will have your own keys. You will be, staking your own 32 ETH. Pool staking is, one of the way where if you are not willing to stake 32 ETH at once, then, we can create a smart contract system wherein you are pooling the ETH from certain users. And then you can assign those ETH once they are in multiples of 32 ETH to the node operators, right? So that creates a whole, big system where each and every participant in the network needs to be incentivized, and that's what gives rights. That is something that gave rise to liquid staking. And then we have got centralized exchanges like Binance, Coinbase that allow staking of Ethereum, where you don't really have access to the infrastructure. You don't really have access to keys, etc. So these are some of the options which are currently available for staking. So what we will be talking about is the pool staking, because that's where the use of smart contracts and liquid staking and a lot of deep liquidity applications come into play. So we have got some external DeFi protocol which is one of the source for getting yield to the user on any stable coin or any governance token that the user holds. And then we have got a staking pool, right, which is something that will be pooling the ETH from various users in different amounts. You can some of the protocols, some of the staking protocols or liquid staking protocols, they allow as low as 0.1 ETH, right? So user will be able to delegate their stake to this liquid staking contract. And then what this liquid staking contract do is they're going to assign those stakes to different node operators in multiples of 32 ETH. Of course, those node operators needs to incentivize. So those node operators will be receiving the operator fee. That is something which is programmed in this staking pool contracts. As a proof, the user will be receiving a token which we called as a staked ETH token. Now, this staked ETH token can be used in other DeFi protocols as well, which I'm going to talk in a bit. And also, the staking pool contract system will be the one that is going to receive the rewards, that the node operator, that is going to happen because of the node operators who will be validating or who will be, participating in the Ethereum network. So all those rewards are, transferred to the staking pool, and that is what is going to, eventually accrue some interest over the deposit of ETH that the user made. This will be operated there. Of course, there are a lot of developers involved. There will be a lot of infrastructure that will be involved. So all those needs to be compensated. So there will be some fee that is going to be there. Usually, when the user would like to unstake their ETH, is when the staking pool will be taking some withdrawal fees. Some of them also take the fees on deposits as well, like when they stake. So that goes to DAO Treasury, which could be a multi-sig wallet or it could be an EOA, and depending on their agreements internally, they can distribute, the fees in the form of compensation, right? So this is basically how the liquid staking works. Of course, there is a risk which you can see is the user will not have any control over the infrastructure. So if the node operator who is working, who is running maybe his own infrastructure or using some cloud services like Amazon, Google Cloud, etc. So they might go down or they might have some compliance issue because of which they might have to take it down. So of course there will be a risk to it. However, there are some protocols like Rocket Pool. They ask the node operators or they mandate the node operators to stake some of their ETH in the network in order to become a validator for their staking protocol, right? And not only that, they also mandate the node operators to, bond some of the governance tokens. Of course, node operator will have to go to the open market, buy the governance tokens of the DAO, and then they'll have to, bond it with the network, so that in future, if it's not performing fine, or if they just went offline, the protocol, can just sell off those bonds, and they can recover the losses or the potential losses that can happen because of node operator not working well, right? So this is all the logic that is realized within the smart contracts. So liquid token design is, so we're gonna talk about, the 360-degree of who are involved and how the reward mechanism works. So there are, fungible there is fungible rewards which are, shared among all the node operators, including the users. There are non-fungible, which are just specific to the node or validator, depending on their depending on the behavior of their behavior in the network. And it could be like combination of both, right? How is the value of token backed? So of course we have got, ETH collateral. So user deposits ETH. So there will be, a backing. So that the staked ETH token, which is issued by the staking protocol, will have a backup of, ETH collateral, either in the form of, liquid cash, or either in the form of, token locked on the Bacon chain. They have got slashing protection as well by asking the node operators to bond some of the governance tokens, and of course some ETH, so that in case of, bad behavior, the governance can come in and they can sell off those bonds and recover the losses. So rewards can be of, two types, either rebasing or non-rebasing. Rebasing are the, rebasing is a mechanism in which you're gonna get the staked, or you're gonna get the, exit amount of token that you deposited, which is so that in case the exchange rate is 1-to-1 and the quantity is linear. However, when we talk about the non-rebasing token, the quantity is constant, but the exchange value, can increase, or it can go it can increase in a linear fashion. There is another advantage of, staking protocol where we can have, liquidity. So you can configure your protocol wherein 10% of the total deposits, or 10% of the net deposits that the protocol has received so far, can be allocated towards buffer, so that that liquid cash can be used for, entertaining any of the unstaking requests that a user might potentially have. Also, that liquidity, or also the staked ETH token which the user is going to receive, you can make a pool on any, decentralized exchanges, and you can allow the users to trade on the secondary market, where, some of the secondary market can present some liquidity discount by offering some of the DAO's governance tokens. And also the primary mechanism can allow some direct, staking, unstaking, so that it can allow the holder to unstake the token without any slippage. For example, if you talk about Lido, so Lido provides a Lido staked ETH token. You wanted to earn some rewards from the Bacon chain, but you don't have 32 ETH, so you went to Lido. You deposited 1 ETH, and now you just want to unstake those 1 ETH. So there are two ways. Either you can go to Lido and withdraw it, or you can go to some, token pair contracts and just swap your, Lido staked token for ETH, right? And that can happen without slippage as well by using, protocols like Curve Finance. So this liquidity tokens, or this, ETH liquidity tokens, can have utility on some of the liquidity platforms, like, adding liquidity to the token pairs on Uniswap, etc. You can use it on oracles as well, like Chainlink oracles employs a lot of liquidity stake tokens, which gives you equivalent price in ETH and USD. You can use that in lending protocols as well, wherein your liquidity tokens are going to act as a collateral, and then you can borrow some of the assets. You can trade it, and once you are done using it, you can just repay. Of course, your collateral token is still going to earn the lending interest rate, even though you did a borrow, and your borrow, I mean, you will be paying some interest on the borrow. So if you make a delta, you might earn some profit on that. And its utility is also inside the yield strategies, which we will be talking in a bit. So if you talk about the user flow, this is what we were discussing from the viewpoint of the operator. From the user interaction point of view, what you need to do is you can just deposit the native asset, for example ETH, to the liquid staking protocol. The liquid staking protocol is going to mint equivalent amount of LSD token, liquidity staked derivative token is what we call, and any rewards that the validator are going to earn will be received by the liquid staking protocol. That will eventually accrue the value for the LSD token that the user received. So that's a flow of a very simple liquid staking protocol. This is a specific example from Lido Finance as to how the Lido Finance works. So a user can deposit ETH, which we call it as the ETH depositors, and there will be operators who are going to who are approved by the Lido DAO to make validations. So they'll be getting a bit of operator fee, and because they are the one who are running the ETH validators and who are running big computers for the validators, right? So they'll start validating. They're gonna earn the staking rewards. They are going to earn the rewards from by validating the blocks, by proposing the blocks, by attesting the blocks, and that will be added to the staking pool. The staking pool is going to get increased with the amount of ETH that it's gonna have. So of course, the price of the staked ETH that the ETH depositor received is going to go up. So tomorrow when they're gonna on stake, they will be receiving comparatively more amount of ETH as a result of receiving more rewards. And of course, depending on the protocol's fee incentive, there will be some fee that will be received by the DAO treasury upon withdrawal or upon redemption of the LSD token. So mostly there are two opportunities which you have of liquid staking derivative. One is you can create a liquidity pool contract. So you can seed a pool where you can pair it up with, say, for example, ETH and an LSD token. So what can happen is if you are the liquidity providers, whenever there is a swap happening, there will be trading fees which you can earn. I think there are 0.05% or 0.03% trading fees on Uniswap V2 if you seeded the liquidity there. So whatever LSD token that you are earning, that you got, is already accruing the value on the original staking pool which you interacted with, and on the top of that, you are also receiving the trading fees, right? Another use case is in peer-to-peer lending and borrowing. So you can lend your LSDs and you can then borrow the assets, making sure that you are maintaining the health factor. Of course, you'll have to get through some rigorous process of getting your LSD whitelisted on lending protocols like Aave Compound. There is a risk in LSD, which we call it as the cartelization risk. So what happens is Lido was like the first player in this space, so it has more than 30% of entire staked Ethereum compared to other protocols. So there is a risk of posing a threat on proposing the blocks, getting the MEV rewards, and also concentrating the rewards that will be earned. There are a lot of ways through which it can be avoided. For example, and of course it can be done by Lido itself, by having a governance mechanism for allowing the node operators, or they can provide the governance powers to the staked ETH holder, so that they can limit the amount of ETH that will get deposited to their staking pool contract, right? If we talk about current trends, I'm not gonna talk a lot about it, but restaking is one of the hot use case right now for for doing a deep liquidity of staked ETH tokens. Decentralized validator technology by SSV network is also one of the advancement in this space. Frex Finance is developing Frex ETH v2 for relending, wherein you can actually create your own sub validator pool, and whatever rewards that you are going to earn, you can land it to other users, so they will be paying some borrow interest. So you are going to earn, of course, the rewards from the beacon chain, and on the top of that you can land those rewards and you can earn more interest on it, right? Because these are some of the advancements, and right now it is being worked. All right, so I want to open up the floor for the questions if you have.
Well, I guess I'm not seeing any questions come in the chat. Is there? Doesn't look like it. Okay, well, Dhruvin, thank you so much for doing this presentation for us. We really appreciate it, and I hope everybody here learned something. We will be posting this up, and if you do have any questions, please ask away. As we want to keep these conversations. We appreciate all the help that we've got from York University, and hopefully we'll be having a second one here in 2 or 3 months. So if anybody has.
Sorry, Jade, there are a couple questions in there now.
Okay. All right. Can you see him, Dhruvin?
I can't.
Question one says, hi, thanks a lot for the presentation. Do we need specific hardware using staking pool? This is a question for Jerome.
You don't need any hardware if you want to stake using a staking pool. That's the whole point of liquid staking.
The other question is from Raphael. What are the advantages a small list provider can offer over big players like Lido? Are there any?
I am not sure if there are any big players than Lido, but there are a lot. There's like Rocket Pool, Dinero, Frex Finance, Stakefish, and there are other couple, but these are like the most known.
Jerome said, thanks a lot. Okay, so there's no other questions, just those two in there.
Oh, excellent. If
Awesome.
has a question, we'll tag Dhruvin in the link. Any questions, and again, any information that you require or want to know about the Canadian Blockchain Consortium, please visit our website. It is in the chat, canadablockchain.ca, and we appreciate everybody for coming out today, and we hope you enjoy the rest of your Tuesday. Have a great day, everybody. Bye-bye.
Thanks, everyone. Bye.